Video we're going to do the proof by first principles of the derivative of cosine x. Now it would help if you've watched the same kind of video with sine x, because you'll have some idea behind it. So first of all, the way I do first principles differentiation is to have x1 as x, x2, beg your pardon, this should be a 2 here, as x plus h. y1 becomes cosine x and y2 becomes cosine, and this replaced with x plus h. And I have my gradient function as this. My gradient function is dy by dx. So I take dy by dx and I put y2 take away y1, x2 take away x1. That should all be quite familiar to you. Now, same as before, I want to replace this using an identity. Now this identity again is a higher level identity, compound angle identity. It's not used at SL, so you shouldn't ever be asked to do this at SL. However, it really helps your understanding to know about these things. So I've replaced this thing here, just the first bracket, with this long explanation here. Here it is. So cosine x, cosine h, minus sine x, sine h, and I've still got the cosine x. And of course on the bottom I've cancelled out these x's, as always happens. So I've got this. That's represented here on the next bit. Like before, I'm going to run my cosines next to each other, so that now I have the cosines cosine x, cosine h, minus cosine x, if you like. I've just moved this into here, and I've got these here, allowing me to factorize this part. Now I've factorized that part and put it over h, take away what I've left over h. And the reason I want to do this is because I want to move towards looking again at the limits of h. As h moves towards 0, what happens? Well, let me just, like I did before, concentrate on this bit here. As h goes towards 0, that bit there goes towards 0. And I've got the graph here. That graph is this one here. As it goes towards 0, h towards 0, it becomes 0. And the second one, I'm going to take just the h parts here. And if I reveal this now, as that goes towards 0, this becomes 1. And again, I can just show you using my graph. There's the graph of that function. As it goes towards 0, I get 1. And you can try it with some small values of h, like 0.01, and you'll get 1. So what happens is, this whole part here becomes 1. This part here becomes 0, so I can ignore this completely. And this becomes 1, so I leave this in here. Negative sine x times 1. And so eventually I find that my dy by dx is negative sine x.